so for 6.2, law of cosines, we actually have law of cosines and then an area formula when it comes to triangles that are not right triangles, what you can use. Law of cosines. And then we're going to do Heron's formula for area. Okay, so let's start with law of cosines. We're going to develop it right quick, okay? Alright, so say we have a triangle in the xy coordinate plane. And it's not a right triangle, so we're talking about, sorry, you're at an angle. Okay, you got the coordinate point, well, okay, let's go ahead and label angle A, angle A, side A, angle C, side C, and then angle B and side B. We're gonna indicate these two lengths right here. Okay, so we've got this length to get to the height, although I kind of veered, didn't I? Okay, so this x length and then this y length, right? Where the y is the height and the x is the horizontal length to get to the height. Yeah? Okay. We have a couple coordinate points that we know. We know this is the coordinate point over x up y, so xy. We know this is the coordinate point c0, yeah, over c and up 0. And a couple other things we know. We know that cosine of angle A, so cosine of angle A equals adjacent over hypotenuse. So this is that right triangle, right? You can only use right triangle trig like cosine, and the terms adjacent, opposite, and hypotenuse when you have a hypotenuse, which is only when you have a right triangle. So cosine of angle A is x over b, and sine of angle A is y over b. Okay? What we're going to do is we're going to talk about the length of A, finding the length of A. So A is this length between these two coordinate points, so I'm going to set up the Pythagorean theorem. I know, I guess in my mind of doing Pythagorean theorem, I can think of it as, this triangle right here, or I can think of it as distance formula. I kind of like Pythagorean theorem, so I think I'm going to go with that. So a squared equals this length squared plus this length squared, right? So as far as this length goes, the whole thing is c, and then this part is x, so then this part right here is going to be c minus x. So the hypotenuse squared equals a squared, or c, I'm not going to use a, b, and c because that's confusing. Hypotenuse squared equals leg squared plus leg squared. And this leg is just length y. Okay? And if we had done the distance formula, then we would have said a equals the square root of x minus x, or x minus x over y minus y, or not over, x minus x quantity squared plus y minus y quantity squared, and then that would have been the same thing we got right here. Okay, so I'm going to solve for a by taking the square root. No, I'm not. I'm just going to keep it as a squared. Okay. I'm going to expand that out, though. So I've got c squared, so c minus x times c minus x is c squared minus cx minus cx, so that's minus 2cx, and then plus x squared plus y squared. Okay. So, what I want to do now is I've got a's and c's, but I've also got x's and y's, and those are kind of different things that we're dealing with. A's and c's are both parts of the larger triangle, so I'd like to replace those. So here's what I know. I know, going back up to this, that x is equivalent to b times cosine of a. So right here, I'm going to replace it with a b cosine of a, and right there. And then right here, I've got that y equals b sine of a. So I'm going to replace y with b sine of a. And so here we go. A a squared equals c squared minus 2cb cosine a, so I just replaced it, plus b cosine a quantity squared plus, I didn't leave myself enough space, b sine a squared. Okay, so I'm going to move that out a little bit. A squared equals c squared minus 2, I'm going to put those in order, bc, cosine of angle A, plus b squared cosine squared, because that's just squaring both of them, and then plus b squared sine squared. Okay. Now these two terms right here have a b squared in them, so if I factor out a b squared, and especially because I notice what I'm left with, cosine squared plus sine squared, but we know by now that Pythagorean identity says that sine squared plus cosine squared of any angle is 1. So I'm left with this minus this plus this. So I'm going to put this in order. I'm going to put the b squared out front. So I'm going to say a squared equals b squared plus c squared, because we were adding this b squared, right? Minus 2bc times the cosine of angle A. And that is a way for us to solve for either lowercase a, side A, or angle A, because there's only one angle A, there's only one capital A variable, and there's only one lowercase a. So I could say A equals the square root of b squared plus c squared minus 2bc cosine of angle A, or I could say that angle A equals, so let's talk about what we would have to do to solve for angle A. We would have to subtract that and subtract that, so a squared minus b squared minus c squared, and then we'd have to divide by negative 2bc, and then we'd have to get rid of the cosine, and that's using cosine inverse. It undoes the operation. So we could have, oh, you didn't even see any of that. Okay. So solving for angle A, I would first subtract these two. So that's the numerator. Divide by negative 2bc. I forgot my c, didn't I? bc cosine A. Wow. Okay. Divide by negative 2bc, and then take the cosine inverse. And that would solve for angle A. So let's talk about what this is given, okay? Because you got to understand why we would even want to do this. In law of sines, we're given an angle and a side pair, and you're supposed to find an angle or a side, right? Given another piece, one of the other two, okay? In this case, if you think about how, like, if I wanted to solve for side A, I need to be able to plug in side B, side C, and angle A. So let's just draw a generic whatever triangle, okay? I'm going to label this A, B, C. Side A, side B, side C. That would mean I would have to be able to plug in side B, side C, and angle A, which means this is a situation where you do not have an angle and a side pair. You only have, you have two sides and the included angle, so the angle in between them, okay? So law of sines is used when you have an angle and a side pair. Law of cosines is used whenever you're not, whenever you're just given these three pieces of information. Two legs and the included angle. Okay. So that's the formula, law of cosines. Now, this is an A and a B and a C, B, C, and then cosine angle A. So, okay. A squared equals B squared plus C squared minus 2BC cosine of angle A, or you could say A equals the square root of that, right? But that means it's also true that B squared equals A squared plus C squared minus 2AC times the cosine of angle B, so that should match that. And that means that C squared equals A squared plus B squared minus 2AB cosine of angle C. And so we can use any of those, okay, depending on what we want to find out. Alright, so let's talk about a triangle. If I give you homework, if I give you side B equals 12, side C equals 7, and angle A equals 55 degrees, and I ask you to solve the triangle, then you're being asked to find all the rest of the information. So you need to find angle B, you need to find angle C, and you need to find, find lowercase a, side A, right? As far as what we can do first, I'm thinking we're going to solve for side A using the law of cosines. So I know that a equals the square root. I'm just going to go ahead and write out the formula. B squared plus C squared minus 2BC cosine of angle A, and then we'll fill it in. So A equals the square root of B squared plus C squared minus 2 times B times C times the cosine of angle A. And we type that in and we get our answer. So we've got the square root of 144 plus 49 minus 2 times 12 times 7 times the cosine of 55. Yeah. And I get 9.831. Okay. So I get side A is 9.831. So we were given a triangle with an angle of A is 55 degrees. We were given side C is 7, and we were given side B is 12, so it's a little bit longer. And we were supposed to find the measure of, so, you know, with law of cosines, this is exactly this length and this is exactly this length. There's no ambiguity about where this goes. It has to go from point to point. So you don't have that possibility of multiple triangles. But we do want to make sure that this makes sense. So this has to be angle C, this has to be angle B, and we just solve for side A. So side A is 9.831. So I better make sure that when I find my angles that that 55 is between the two angles C and B, because C should have the shortest angle and B should have the largest angle. Okay, or smallest angle, I should say. Okay, now that we have this, we could do law of sines. Okay, we can also do law of cosines. I think I'm going to do both and see if we get the same thing. Okay, I'm first going to do law of cosines. So I'm trying to solve for angle C, given A, B, and C. Yeah, because in this formula, if I know A, B, and C, I forgot it again. A, B, and C, then I can solve for cosine of it. I can solve for A. Anyway, okay. So what I want to do is I want to, give me 1 second. I'm waiting on a response from somebody. Alright, so I'm going to set up law of cosines only. I'm going to set it up with angle C being the part at the end, right? So that means C squared equals A squared plus B squared minus 2AB cosine of angle C. So whichever angle is the one that you're trying to solve for, that's the one that needs to go on this side of this, right? Okay, so I'm trying to solve for angle C, given sides A, B, and C. So this is another way that law of cosines can be used. Given 3 sides, can you find an angle? Okay, so we're going to take C squared, 49. We're going to subtract A squared, 9.831 squared. We're going to subtract 12 squared, B squared, right? So we subtracted A squared, we subtracted B squared. So those are gone. Now we're going to, we've got like this equals this expression over here, right? We need to divide by negative 2AB, and it's okay if we put the negative down there. Just don't float the negative to the top and only apply it to the 49. It would be both of those. All of those would change. Negative, positive, positive. As it is, I'm going to say negative 2 times A, which is 9.831, and B, which is 12. And so then that would be gone, and then we would just be left with cosine of angle C, so we would take the cosine inverse of that. And that equals angle C. So I'm going to type that in. Only this time we're going to be a little bit careful about how we type it in. I'm going to say cosine inverse. And I'm going to go ahead and use this because why not? You can't see the parentheses, so like from end to end to know whether or not you're doing it, you could see whether or not I'm doing it correctly, so I'm going to just go ahead and do it this way. 49 minus 9.831 squared negative 2 times 9.831 times 12. So if you're worried about the negative, because this is 49 minus larger numbers, that negative and the negative in the numerator will go away. So I'm left with 35.682 degrees. So that means angle C is 35.682 degrees. Okay. And if I know this angle and I know this angle, then I can subtract from 180 to find that angle. So 180 minus what we have, minus 55, and we get 89.318. 89.318 degrees. So we have officially solved the triangle because we have all 6 parts. All 3 angles, all 3 sides. Okay? I did say I was going to look at law of sine, so I'm going to look at that real quick. If I'm trying to solve for angle C, sine of angle C over C, which is 7, equals, and then we go with an angle and a side pair that we were, I had to find A. Oh yeah, once I found A. Okay. So then angle, so sine of 55 divided by 9.831. So this is law of sines after law of cosines. Then I would multiply by 7 and then take the sine inverse. So sine inverse. Hey, and what? Because I'm doing this fraction, that made me think. I'm gonna go ahead and type it in, but sine 7 sine of 55 divided by 9.831, and I get 35.680, which is close. It's almost the exact same thing we got. It's off by 2. Interesting. So this says the angle C equals 35.680. If you show me your work, then you're fine. Okay, so no worries if you're off by that much. I do want to say, the reason why you need to be careful about typing this in is if you type in 49 minus this squared, and then you say divided by, and then you just start typing in negative 2 times this, without parentheses, you're gonna have basically this: 49 minus 9.831 squared minus 12 squared divided by negative 2, and then the whole answer, this part, just this part, times 9.831 times 12 in the numerator, because it will not divide it in the denominator unless you put it in the denominator. You would have to put parentheses around the denominator and parentheses around the whole numerator. So it's a little bit easier just to type it in as the fraction. Okay, let's go with another triangle. Only this time what I'm going to do is I'm just going to ask you to solve for one of the angles, okay? I'm going to give you A equals 10, side A equals 10, B equals 7, and C equals 5. And I'm going to ask you to solve for angle A. Of angle A. Okay, so if I'm trying to find angle A, given these 3 side lengths, what I want to do is I want to set up the law of cosines with A being on either side. So A squared equals B squared plus C squared minus 2BC times the cosine of angle A. I didn't forget the C this time. Okay, so A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. So 100 minus 49 minus 25 divided by negative 2 times 7 times 5, and then we take the cosine inverse of all that and we're left with angle A. Okay, so cosine inverse. Let's also make sure this makes sense, okay, before I find my answer. I've got a triangle with a side length of 10, a side length of 7. Let's see. Okay, 7 and 5 are both shorter than 10, so that means it's going to have to kind of bow in. Let's see, this 5, half that length, and then 7. Yeah? That looks like it could be kind of it. Something like that. So this supposed to be A equals 10, B equals 7, and C equals 5. Okay, so just as a visualization. So I definitely should have a larger angle considering the fact that I'm dealing with the largest side. Okay. Cosine inverse fraction, so that's alpha y equals to do the fraction, or just do parentheses, okay? So if you do parentheses and then do the whole numerator, right? 100 minus 49 minus 25, a separate parentheses from the first one. 100 minus 49 minus 25, close that parentheses. Divided by, open another set of parentheses, negative 2 times 7 times 5. And then close your parentheses again, and you're left with 111.804. 111.804. So that means angle A is 111.804 degrees, and that makes sense for that angle right there. Makes sense that it would be an obtuse angle. Okay? Alright. So, I have another situation where I asked, in my notes, I asked my students to solve the triangle, so that means solve for everything. And I gave them the side lengths A equals 1, B equals 5, and C equals 4. Now, if you just start working this, you start working along, you're like, okay, I've got a side length of 5, I got a side length of 4, and I've got a side length of 1, so 4's got to be this, yeah? And you just draw it thinking, sure, that's going to be it, right? Well, some of you probably have already noticed the problem. 4 plus 1 is 5. So as far as a triangle goes, that would be like saying, create this triangle. If you put, like, this length, right, the full pen, and then you have another pen to make it with, right? So the two sides add up to this pen. So if I try and, like, not like I can't just connect them, I gotta put them, right, that? It would just create two lines on top of each other. You don't have enough to create another triangle. There's a theorem that says that the two shorter sides must add up to greater than the longer side, the longest side. And so this would actually just collapse on itself and create a triangle. If we wanted to prove that, let's find the measure of the angle across from this side. Okay, and if you think about this, if this should collapse and create that, then it should be 180 degrees because it should be a line, right? But as far as solving that, if you try and set it up and say, okay, I'm going to let this be, this is B. A and C. So we're trying to solve for angle B. So that would be, we set B, right? I'm going to go ahead and say B squared equals A squared plus C squared minus 2AC cosine of angle B. So whatever this angle is, or whatever this side length is, that's the angle. And then the other two sides go in there. So that means B squared, 25. I'm going to subtract A squared, subtract C squared, which is going to be 16. Divided by negative 2 times A times C, so 1 times 4. And then take the cosine inverse of that. And that would be angle B. So cosine inverse. And if you notice the problem already, it's that when I subtract in the numerator, I don't get a negative number. I forgot my own piece of advice. So close parentheses divided by negative 2 times 1 times 4. And I get 180 degrees. So I do get that this right here is 180 degrees, which makes it a line, right? So it would just land on top of it. So if you have 5 and then you have 4 and then you have 1, yeah, 4 would be more like right over here. Whatever. They would just collapse and land on top of that, the horizontal length anyway. Okay, so we would say not a triangle, even though I guess you could say it's a triangle with two angles at 0 degrees and one at 180. Okay, so let's talk about Heron's formula. So last thing. Wow, I just made the comma an S with the apostrophe. Heron's formula. My handwriting is getting so bad, guys. I'm just gonna... Okay. So Heron's formula has to do with finding the area of a triangle. Because see, well, given specific piece of information, you have 1/2 base times height. So if you can find the height, I mean whatever, 1/2 base times height, and it's the height depending on whatever the base is, right? So if you've got a weird triangle going on, something like this, if you orient it this way, then here's the height, right? If you let this be the base, right, then here's the height with the base. And if you let this be the base, then here's the height. So it doesn't really matter, it's however you see the triangle, but that's if you're given enough to be able to figure that out. With Heron's formula, it's can you find it with a non-right triangle, obviously, and then given 3 side lengths. So given A, B, and C. Alright, so here's the thing. First, we established what the letter S is going to stand for. That S is going to stand for half of the perimeter. A plus B plus C. Okay, so half the perimeter. And then Heron's formula says area equals the square root of side times side. S, which is half the perimeter, times half the perimeter minus A, times half the perimeter minus B, times half the perimeter minus C. And that's how you solve for the area. Okay, so half the perimeter times half the perimeter minus A minus B minus C, and then take the square root of that, and you've got the area of your triangle. So if I give you a triangle with side lengths A equals 5, B equals 12, and C equals 14, and I asked you to find the area, then first you would do S equals 1/2, 5 plus 12 plus 14, which is 26/31, so half of 31, or 15.5. Okay, so area equals half the perimeter, 15.5, times half the perimeter, 15.5 minus A, times half the perimeter, 15.5 minus B, times half the perimeter, 15.5 minus C. So if you wanted to, instead of writing all that out, if you put 15.5 times 5 times 3, 5.5. I'm sorry, my brain is just not with me right now. 3.5 and 1.5. Then you could type it in and there's your answer. Okay. I am going to end the video because I think my dog just got something stuck on her.